Okay, now we're going to get into a little bit of the graphing of these rational functions. So we're going to build on what we already did. Okay, so the first step is going to be to figure out what the asymptotes are, which you've already done. So we'll go over that just a little bit again. So we're going to have, again, a constant over a linear. Okay, so we know, again, that vertical asymptote will be whatever makes the denominator 0. Okay, so x equals 4 will be a vertical asymptote. I suppose I should write asymptotes. Okay, and then the horizontal one, remember, again, when we first did these, I said these are just always going to be y equals 0. And then later on we said, well, anytime the degree of the numerator is less than the denominator, that horizontal asymptote is y equals 0. Okay, so we're going to start with the asymptotes, and we'll do that right now. Okay, so we have an asymptote at x equals 4 and y equals 0. Okay, and then the next thing it tells you to do is plot 2 points on each piece of the graph. So remember, this graph is going to have 2 pieces to it, something like this. They're called branches, actually. And we're going to find, they want 2 points on each, so a total of 4 points. Okay, so your best bet here is just move out from that vertical asymptote. Okay, so we can make a little table of values here with x and y, and we'll put 4 in the middle. That's where our function is undefined, which is what makes that asymptote at x equals 4. And so we'll find our points when x is 3, when x is 2, when x is 5, and when x is 6. Okay, and you literally just plug them into the function. So f of 2 would be negative 4 over 2 minus 4, which is negative 4 over negative 2. Okay, so that's going to be positive 2. All right, and then the next one is f of 3. So we'll have negative 4 over 3 minus 4, which is negative 4 over negative 1, so just 4. Okay, and then we'll have f of 5, which is negative 4 over 5 minus 4, which is negative 4 over 1, so that's negative 4. And yes, you are going to see some symmetry here. F of 6 would be negative 4 over 6 minus 4, so negative 4 over 2, which is negative 2. Okay, and so that's all the points we need. We can plot them now. So the first point is when x is 2, y is 2. The next one, when x is 3, y is 4. Okay, and then when x is 5, y is negative 4. And when x is 6, y is negative 2. Okay, and then we're going to just fill in that shape. Okay, so connect those 2 points with a curve, and then just get closer and closer to an asymptote, closer and closer to an asymptote. Remember, we're not going to cross the asymptotes. Okay, closer and closer, closer and closer. All right. Okay, we got another graph now. Oops, I just closed my window. Hold on a second. Okay, graphing a rational function when we have linear over linear. Okay, so same thing where they want you to graph the asymptotes and some 2 points on each branch. Okay, so we have f of x equals 2x plus 3 over x plus 3. So again, your asymptotes, your vertical, will make the denominator 0. Okay, so x plus 0 will be 0 and x is negative 3. And your horizontal, remember for this one, the degrees are the same. So it's the ratio of those leading terms. So it'd be y equals 2 over 1, or just 2. Okay. So again, we can start with that. Okay. Okay, so x is -3 and y is +2. Okay, so I got my asymptotes drawn in. Now I'm going to make my table. Okay, when x is -3, our function is undefined. So I'm going to get my points at -4, -5, -2, and -1. Okay? All right, f of -5 will be 2 times -5 plus 3 over -5 plus 3. So that's going to be -10 plus 3, so -7, over -5 plus 3, which is -2. Okay, so that's -7, or sorry, +7 halves. Excuse me. Okay, so I can graph 7 halves, which is also 3.5. If you want to do it that way. Okay, f of -4 then will be 2 times -4 plus 3 over -4 plus 3. So that will be -8 plus 3, which is -5, over -4 plus 3, which is -1, which is going to be 5. Okay. F of -2 will be 2 times -2 plus 3 over -2 plus 3. So I have -4 plus 3, which is -1. -2 plus 3 is 1. So that's -1, yeah. Okay. And then f of -1, which will be 2 times -1 plus 3 over -1 plus 3. So we have -2 plus 3, which is 1, -1 plus 3, which is 2. So we have 1/2. Okay. One thing that you're going to notice is that the symmetry here is that they're the same distance from the horizontal asymptote. So when I graph -5 and then 3.5, and when I graph -1 and -1/2. So for both those points, I'm 2 units away from the vertical asymptote. Okay, this distance is 2. And they're both the same distance from the horizontal asymptote. So this is 1.5, and this is 1.5. So you'll see that kind of symmetry there. Okay, so the next, when we're 1 unit away, at -4, +5. Okay, so that's 1 unit to the left of the vertical asymptote and 3 units above the horizontal. So if I go 1 unit to the right, I'll be 3 units below. Okay, so that's -2, -1. Okay, connect the points with the curve. This one's kind of a weird, kind of a tougher one to draw, I guess, but then -1, that's why, because this should be -1, 1/2, not -1/2. There you go. I was wondering why that wasn't working out so well. And then this one up here. Okay, so you got your 2 points in your set. All right, we have one more topic, module 15. I think this is one of the tougher modules so far. Okay, so the next one is just a transformation. Same transformation rules as any other graph, so don't get confused here. We are going to transform the graph of a rational function. Okay, so we are going to be given the graph like y equals 1 over x squared, or maybe y equals 1 over x, okay? And we want to transform it to be y equals 3 over x minus 2 squared. Okay, so remember, it's going to be the same basic shape. So if we have a over x minus h squared plus k. All right, so when we multiply that expression by a, that's a stretch factor. When we replace x with x minus h moves it to the right. If we add k moves it up. Okay, so the one that we have here is going to be stretched by 3, stretched by a factor of 3. And we're going to move it to the right 2. Okay, so our original graph that they give you looks like this. Oh, that's not as curved as I wanted. Here, let me fix that. And one point that is always going to be on these is 1, 1, or some positive, negative 1, positive, negative 1. Okay. So yeah, since it's the x squared, we have this kind of funnel shape here. And 1, 1 and negative 1, 1 are on the graph. Okay, so the first thing that you're going to do is move it to the right 2 units. I'm just checking here to make sure that that's what they want you to do. Looks like it. Okay. So I'm also going to draw in the asymptotes. Okay. So we're going to move it to the right 2 units, and we're also going to stretch it by a factor of 3. Now, some kids get confused on that stretch factor. These points are 1 unit from the horizontal and 1 unit from the vertical. Okay, and they always will be. They might be down or to the left instead, but it's always 1 unit. So we're going to multiply that vertical distance by 3. So we're still going to go left and right, just 1 unit, but instead of going up 1, we're going to go up 3. Okay, so that's how it's going to stretch this. So if we do that at the same time, okay, so negative 1, 1 will go to negative 1, 3 when I stretch it. 1, 1 will go to 1, 3. And then I have to also move it to the right 2. So this will go to actually positive 1, 3, and this will actually go to 3, 3. Okay, and move your asymptotes also. Okay, so everything, this asymptote that is at x equals 0 will be at x equals 2. It's kind of a lot to put together, so take your time. So x equals 2. That horizontal asymptote, if I shift it right, it doesn't really make a difference, right? It's just a line. So this will still be at y equals 0. And then I'll go again here. This is at 1, 2, 3. 1, 2, 3. Okay. So this point, I need to shift it 2 to the right, but then also get stretch factor. So rather than being 1 above the horizontal axis, it's going to be 3 above the horizontal axis. So that's going to take me to 3, 3. Okay, this point here also, I'm going to move it to the right 2 units. Okay, and then stretch it. So rather than being 1 away, it's going to be 3 away. So this will be at 1, 3. Okay, and then my graph is going to look like this. Okay, that red graph there. Let me get you another one because there's a lot here. A lot going on. Okay, the next one here we've got y equals 1 over x, and they want us to do y equals 2 over x minus 4. Okay, so again, that's a stretch by 2, and then we're going to move it down 4. Okay, so the original graph, oop, that's not good. Let me get a better grid there for you. I should just do that. Why haven't I been doing that? That's ridiculous. I'm almost embarrassed. Okay, so 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Negative 1, negative 2, negative 3, negative 4, negative 5, negative 1, negative 2, negative 3, negative 4. We'll squeeze that on. Okay, so we've got the point. Actually, just going to use gray with that background one. For y equals 1 over x, Oh, that didn't work. Okay, we've got the curve that looks like this. And we've got the asymptotes that are your axes. Okay, so the asymptote at y equals 0 and the asymptote at x equals 0. Okay, so what we want to do first is shift down 4. Okay, so this horizontal asymptote, instead of being at y equals 0, will be at y equals -4. Oh, I totally drew that wrong. Just the branch I drew wrong. I was doing y equals 1 over x squared again. It's just 1 over x. So we actually need a point here. Okay. But anyway, so when we shift down 4, that horizontal asymptote goes down 4. The vertical asymptote, go ahead and shift it down 4. It's in the same spot. Okay. All right, now this point right here, I'm also going to shift it down 4. 1, 2, 3, 4. That puts me in the same spot, right, where I'm 1 unit to the left of the vertical asymptote, one unit up from the horizontal, but I want to stretch it by 2. So rather than being 1 unit up, I'm going to be 2 units up. Okay, and then I'm also going to shift this other point down 4. 1, 2, 3, 4. But also that stretch of 2. So then rather than being 1 unit away from the horizontal asymptote, I'm going to be 2 units away. Okay, so this point is at 1, -2. This point is at -1, -6. Okay, and I'm going to draw in my shape then. Okay, you might need some practice on those a little bit, and I can help you too. But there you go.